Those are numbers that have the i's in them. So remember, I squared is equal to -1. So we'll need to know that moving forward. We will simplify a lot of these things. Anytime we get an I squared, we can change that to -1. In general, a complex number is something of the form a plus bi. A real part plus an imaginary part. We usually want to write these in standard form, so we always put the real number first and the imaginary number second. I squared is equal to -1. So anytime we get an I squared, we'll change it. So what we're doing today is just a lot of different types of problems that have i's in them. We're just working on simplifying. So whether things have radicals or we're adding, multiplying, we're just going to kind of touch on all of those things that we might encounter moving forward and making sure we know how to simplify. Our first example. If I give you the square root of -1, anytime there's a negative under a radical, we automatically have to put an I. So all this essentially means is you would take out an I, if you pull out the negative it becomes an I, and then it's just I times the square root of 1. But what is the square root of 1? 1. So I times 1 is just I. So the square root of -1 would just turn into an I. If I give you the square root of -16, what would that be?
I square root of 16.
Take out your I times the square root of 16. The square root of 16 is 4, so I times 4, we would just write 4i. Square root of -8. So sometimes we can break these radicals down perfectly, sometimes we cannot, but we've broken down radicals before. The only difference on this is because of the negative, we do have to take out an I. Then how would you break apart 8? What could you turn that into? 2. Square root of 4 is 2. So this is just 2i radical 2. So break down your radicals as far as you can, no perfect squares left underneath. And if you have any negatives under the radical, you pull out an I. When we are working with radicals, if you are going to multiply, you have to make sure that you pull out the I first. So, for instance, if I gave you this problem, if you didn't pull out the i's, if you just multiplied, you would get the square root of 36, which is 6. But if I first reduce these radicals, what is the square root of -4? 2i. What is the square root of -9?
3i.
When you multiply those, you get 6. I times I is I squared. But what did I tell you that I squared was equal to? So that's 6 times -1, which is -6. If you don't pull out the i's, you will get +6 for your answer. So just make sure if you're going to be multiplying with radicals, take out your i's first. So let's do some examples like that. Alright, so on A, square root of -7. What could we do there? Just take an I out. We can't break down the square root of 7. So that's just I radical 7 times I radical 7. When you multiply numbers outside the radicals together. So I times I is I squared. Then you multiply the numbers under the radicals. So 7 times 7 is 49. I squared is, and the square root of 49. So we get negative 7 for our answer. I am going to skip B for a second. I'm going to do C first. When we're dividing, we have two routes we can take. We can break down each of these radicals and reduce. But oftentimes it is easier to realize that if you have the radical on the top and the bottom, you could go ahead and simplify that stuff underneath first. So that's the same as the square root of the whole thing. What is negative 20 divided by negative 2? Negative divided by negative would be a positive 10. Can we break down the square root of 10? No, so that's our final answer. Now you could get it otherwise by pulling out your i's, breaking down your radicals, and you'll get to the same point. But this is a more direct route. When you're dividing, you're welcome to go ahead and divide the two numbers and then do the square root at the end. So I would like for you guys to try B and D on your own. On B, what do you have to do first? We have those negatives, so that means pull out an I. When you multiply these together, I times I gives us I squared. 6 times 10 is 60. Okay, I want these in reduced radical form. So I squared is negative 1. What can you break 60 into? Square root of 4 is 2. We still have the square root of 15. So we get negative 2 radical 15. On D, we have the square root of both of those. So you could simplify each one, or we could make life a little easier and realize we could go ahead and divide first and do the square root at the end. What's negative 48 divided by 24? So the square root of negative 2 is square root of 2. Do we need more examples like these? The next thing I want to talk about is adding, subtracting, multiplying with complex numbers. So essentially, it follows all the same rules for anything else. You add like terms, you subtract like terms. If you're multiplying two complex numbers, we FOIL. So all of our normal rules will still apply here. The only thing we have to watch out for is anytime you get an I squared, you turn it into negative 1. All right, so let's do an addition problem first. If I ask you to do 3 plus 5i plus negative 2 plus 3i. So we're adding. We just add like terms. 3 plus negative 2. 1. 5i plus 3i. 8i. 1 plus 8i is my final answer. I will tell you that when we work with these, I will always say to put it in standard form. So if you write 8i plus 1, that's technically incorrect, just because it's the wrong form. They always want the real number first. It's just a notation thing. If I asked you to subtract, what would you have to do? Distribute that negative. So 6 plus negative 3 is 3. 4i plus negative 6i, negative 2i, so 3 minus 2i. You guys try a couple.
Oh.
Yeah, right?
Yeah.
Okay. So if we add 9 plus negative 3, we get 6. Negative 4i plus 6i is plus 2i. So first one, 6 plus 2i. Second one, distribute the negative. So add like terms, 11 plus negative 4 would be 7. 5i plus I plus 6i. Are we okay with adding and subtracting? Okay. Let's do multiplication. If this were with x's, 5 plus 3x and 2 plus 7x, what would you do? FOIL. So that's exactly what we're going to do here. So 5 times 2 gives me 10. 5 times 7i is 35i. 3i times 2 is 6i. And 3i times 7i is 21i squared. We have 10 plus 35i and 6i are like terms. So that gives me a 41i. What can you do with 21i squared? I squared is negative 1, so 21 times negative 1 is negative 21. Okay, then to finish it, we still have like terms, don't we? 10 and negative 21 gives me negative 11 plus 41i. Again, we just write that real number first for standard form. So FOIL like usual, but when you get an I squared, change it to negative 1. You guys do this one. So we get 5 times negative 2 is negative 10 minus 15i minus 16i minus 24i squared. So negative 15i and negative 16i is negative 31i. Negative 24i squared would turn into, so add like terms, negative 10 plus 24 gives us 14 minus 31i. Do we need more like that? So let's talk about when you have these numbers being divided. We talked about dividing two numbers with radicals. I appreciate that he was paying attention. I remembered we'd done some division. Okay. So we're not going to do anything crazy like long division or anything like that. But we have to be able to write these in standard form, a plus bi. So it is not proper notation to have an I in the denominator. If I have 3 over I, do you have any idea how I could move that I off the bottom? Okay. We know that in a fraction it's legal as long as you multiply by the same thing on both the top and the bottom, right? So I take top and bottom times I. So on the top, 3 times I is 3i. On the bottom, I times I is I squared. But I squared is, so 3i divided by negative 1, negative 3i. Now B. Don't write this down for a second. Let me just, if all I did was multiply by I again. On the bottom, you distribute and you get 5i minus I squared. Is that going to make my I go away? No, it just moved it to the I. So because I have 2 terms on the bottom, we can't just multiply by that I. Does anyone remember what you have to multiply by instead? Yeah, 5 plus I, the conjugate. Just like when we were trying to get radicals off the bottom, you multiply by the conjugate. But we just did examples with multiplying, so this isn't too hard. We can handle that. We have to FOIL. So on the top we get 15 plus 3i plus 10i plus 2i squared. On the bottom, you get 5 times 5 is 25. The positive 5i and the negative 5i cancel. That's why we do the conjugate, so we really just have to multiply first and last. Negative I times I is negative I squared. So on the top we have 15 plus 13i. 2i squared is negative 2. Over 25 minus I squared. Becomes 25 minus negative 1, which is just 26. So on the top, 15 minus 2 is 13 plus 13i over 26. We are actually technically one step away from our answer. So yes, we got the I off the bottom here, but if I ask for a plus bi, you have to separate the real and the imaginary part. So we just have to divide each of these by 26. So 13 divided by 26 is 1/2 plus 13i divided by 26 would be 1/2 I. All right, let's do it. So let's do 4 minus 3i over 4 plus 3. We have to get the I off the bottom. Bless you. So what do I have to multiply by? So the conjugate of the bottom is 4 minus 3i. So on the top, if we start FOILing, 4 times 4 gives us 16 minus 12i minus 12i plus 9i squared. The denominator, when you FOIL, 4 times 4 gives us 16. What happens when you do the outside and the inside, though? They cancel because they're conjugates. You get minus the 12i and plus the 12i. Minus 9i squared. Negative 12i and negative 12i is negative 24i. 9i squared would be a negative 9. On the denominator, 16 minus 9i squared becomes 16 plus 9. So if we add like terms, 16 minus 9 is 7, minus 24i over 25. So to finish it, we just put each one over 25. So 7 over 25 minus the 24i over 25. Or 24 over 25i, you could write it either way. You okay with that? There's one last piece I'd like to talk about, and then I will be done. I am going to jump to this one. So we are going to simplify powers of I here. Basically, if I give you I to the 15, okay, that means you have 15 i's multiplied together. But we can always break this down. Okay, if we think about, let's think about an easier example for a second. If I said I to the 5th, that means you have 5 i's. But when you multiply 2 of them together, what do you get? So if I multiply those 2, I get a negative 1. Then I multiply these 2, and I get a negative 1. And then you have an I left. And that whole thing would turn into an I. So we have to figure out how many groups of 2 we can make. If you have 15, how many groups of 2 i's can you make? 7, right? That would take up 14 of them. So that's I squared to the 7th. That takes care of 14 i's, and we still have 1 I left. Does everybody understand where I got this? What is I squared equal to? Okay, what is negative 1 to the 7th power? If your power is odd, it'll turn out to be a negative 1. If your power is even, it turns out to be positive. So we have negative 1 times I, which is just negative I. So B, I to the 33rd power. So our first question is, how many groups of 2 can we make?
16.
And that takes 2 times 16 is 32. We need 33, so we still have 1 more I. I squared is what is negative 1 to the 16th power?
Negative.
When you if you use the calculator, put the negative 1 in parentheses. Since it's an even power, it should turn out to be a positive 1. So then we have 1 times I, which is I. C, I to the 22nd. We want to know that's 11 groups of 2. 2 times 11 is 22, so there are no leftovers here. I squared is negative 1, and negative 1 to the 11th. Last one, have I to the 12th. So that would be I squared
To the 6.
to the 6. There are no leftovers. I squared is -1, and -1 to the 6th is 1. Those are the only 4 possible answers you'll get. I, -I, 1, or -1 every time.
If it's like an even, like C and D, is it okay if instead of like doing that second step, you just put it
Like -1 to
or
whatever
if
power.
we know?
Yeah, that's fine. Alright, so what we're going to do, we've got a little bit of time left. There is a math Excel assignment for this section. You will have class time tomorrow. We've got the Veterans Day Assembly that kind of messes with my afternoon class, so I'm not teaching anything new tomorrow. So if you don't